So now we're going to go back to the equations that we just looked at and figure out what A, B, and C are, and then we're going to use this equation to figure out what value of x makes this true. So just to recap, you're taking your equation, then you're writing it in the form ax squared plus bx plus c, or x could be any letter, but you're writing it in the squared term, then just the term itself, then the number. And then you can times it by -1 maybe to get rid of negatives if you've got too many negatives, and then you're figuring out what the value of A, B, and C is. Okay, so you have to rearrange first, then find A, B, and C. Then you just plug those into this equation. So the equation we use to solve a quadratic equation is, if it's an x, then it's going to be x is negative b plus or minus the square root of b squared minus 4ac over 2a. And you have to learn that equation. I'm not going to be giving you it in an exam. It is quite a useful equation, so learn it. And so what we usually do first here is we figure out this term first, and then we plug it in just to save writing out b squared minus 4ac multiple times. And so this is two solutions. One of the solutions is negative b plus this divided by 2a. The other solution is negative b minus this divided by 2a. Okay, so first thing is to figure out what's the square root of b squared minus 4ac. Square root b squared minus 4ac. In this case, that is equal to b squared is 16, 4 squared, minus, so what we've got, let's just write it out, minus 4 times a is 6 times negative 10 is c, which is equal to 16. So what we've got here is just look at how many negatives you got. I've got one negative, another negative. So if you've got an even number of negatives, it's going to be positive. So that negative times this negative is going to be positive. So it's going to be 16 plus 4 times 6 times 10 is 240, which is equal to, I've lost my square root of that, square root of that is equal to the square root of 256, which is 16, I think. So then we plug that into this equation. So we have got x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. So therefore we're going to have two solutions. Let's call it x1 is equal to, so b was 4, so negative 4 plus 16 divided by, where did I get the 16 from? It's just this is equal to that. That's what we just figured out. B squared minus 4, square root of b squared minus 4ac is 16. And so minus 4 plus 16a was 6 over 12. And that is equal to 1 because I chose that equation carefully. The other solution is negative b minus this divided by 2a. So therefore x2 is equal to, let's have a look at it here. So we are going to have minus 4 minus 16 over 12, which is equal to minus 20 over 12, which is equal to minus 20 divided by 12 is equal to minus 1.667. Now, this is getting a bit messy, so what I might do, so that we're not losing track of things, I'll just drag these down here for now. And then what I might do is I'll zoom back in, just so that we don't lose that equation up the top there. Okay, let me just pause it a second, I'll just type. Okay, so I've figured out b squared minus 4ac, then I've plugged it into everything into this equation. I've got my two values of x. One of them you're adding this, one of them you're subtracting that. I've got two answers. And so if we've got the right answers, it should make that equation work. So check. So if we stick x1 in there, we're going to get left-hand side is going to be 10. Right-hand side is going to be, so we're just saying x is equal to 1, so we're going to get 4 times. All I'm doing is taking this value, this first solution that I found, I'm sticking it into this. So 4 times 1 plus 6 times 1, which is 10. So x is a solution to this, which is equal to the left-hand side. Okay, so we know that this answer, x is 1, is a solution for that equation, because when you put in x is 1, this is true. And then let's try the other one. So for the left-hand side, x2 into the original equation, left-hand side is equal to 10, right-hand side is equal to 4 times negative 1.667 plus 6 times negative 1.667 squared. If I chuck that in my calculator, I get 10.001, which is near enough given I've rounded that number, 10.01, which is approximately equal to the left-hand side. Okay, so that works. So I've shown that both of these are solution. Now, if this was a practical problem, it might be, say this was time, then you'd have to look at these and decide which one's sensible. You know, is a negative answer sensible? Is 1 second sensible? Or is negative answer sensible? And then choose the answer that's most appropriate for your solution. It might be both of them are an answer. You just have to think about what the problem's saying and try and figure out which of the answers is a sensible answer. Okay, let's try the next one now. I don't know if we really need to do all these because it's essentially the same thing. So what I'll do is just speed through it, and then, oh well, no, let's just go through it so you can see it. So same thing again. So if this was a real problem, we would have been given this, we'd have rearranged it all to figure out what A, B, and C were as we did above. And then again, the first thing you do is figure out this term, b squared minus 4ac, the square root of b squared minus 4ac. In this case, that's equal to the square root of 4.905 squared minus, complete rubbish, b squared minus 4ac, which is equal to 25b squared minus 4 times 4.905 times negative 85. Got to be careful with all your pluses and minuses and stick that in the calculator. This will end up being, so you've got two negatives in that multiplication. You've got the minus 4 at the start, and you've got a minus here, so they're going to cancel out, so you're going to get a positive overall. But if you put it into your calculator carefully, you should still get the right answer. So it's 25 plus 4 times 4.905 times 85. So it's the square root of 1692.7, which is equal to 41.14. So then we can go on to the equation now. So the equation is, the solutions are x equals negative b plus or minus, plus and minus really, b squared minus 4ac over 2a. Therefore, we're going to get two solutions. x1 is going to be negative b minus 5 plus 41.14 over 2 times 4.905. which is going to be equal to, and I'll calculate that in a minute, and then the other solution is going to be minus 5 negative b minus 41.14 over 2 times 4.905. Okay, so this is just this here, negative b is 5. We calculated this already, 2a is 4.905. So that is equal to, let me just calculate both of those. I'll be right back. So I've got those two answers, just calculated those. And now all I'm going to do is to check it, is I'm just going to take these values, put them back in the original equation. To be safe, I'm putting them in the original equation, not the one that I changed to find A, B, and C. So I don't want to put them in this one because I might have made a mistake there. And so I'm going to stick them back into that original equation and just make sure it works. So I'll just pause it while I do that. One thing I've just picked up on there, I'm not being very careful, this is true, x is negative b plus minus, if this is x. It's not. This time it's t. So I need to change these. This should be t is equal to that. And this should be t1 and t2. Okay, and I'll work back through that again. So I've stuck those values into that first equation, and it's both coming out as correct. So I've shown that those are actually solutions to that equation. So the left-hand side is the same as the right-hand side. So I've got the right answer there. And so now I probably won't record this bit. I'm just going to work through and do the same for the last problem. Something fishy going on there. I'll fix that too. And then we can move on to doing some actual dynamics. So I've worked through that last example, much the same, not much to say. The only difference, I guess, is that this time the original equation has that variable on both sides, that v's on both sides. So you have to actually calculate the value for both sides and make sure it's roughly the same. It's a little bit different, but that's just due to the rounding error. It's well within the rounding error. Okay, that's those. Let's move on to the